Okay, today we're going to be looking at sets. Sets are just collections of items, and we're going to look at them in a sort of a mathematical way. So this subject can be considered difficult because there is new language to contend with and new notation. The actual concepts aren't too hard, but the language and notation some students find difficult. We tend to mainly focus on Venn diagrams in set theory, particularly at GCSE. So let's look at some examples to help us develop our new language and notation. Okay, firstly, this is a set. Okay, this is the set of numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9. It's a collection of items. That is all a set is, a collection of items. This little thing here, this is the name of the set, and this symbol represents the universal set, okay, aka the daddy set. All sets will come from the universal set. That will be clear as we go through this example. So this is the universal set. This is the big daddy of the sets. We can also write the universal set as a capital U. So you might not see that funny E symbol, you might just see a U instead. Okay. Now, the collection of items we group together with commas and we put curly brackets around. Okay? If you try drawing a curly bracket yourself, notice how one curly bracket will always look nicer than the other curly bracket. My left curly brackets always look nicer than my right curly brackets. It's just a fact of life. Okay, so sets are collections of items. We put the items within curly brackets. We have a name for the set, and we say that set is equal to these items. Okay, hope you're still with me. Sets are collections of items. Okay, so we can define sets. We can give rules to sets. Now A is the name of a set, and we'll say this. I'll just write it first. This is X. The dot, means such that colon means such that, X such that X is even. Okay, so what does X mean? X is just stuff or items. Items from the universal set. So take items from the universal set such that these items, or this stuff, is even. Okay? Notice how we still have the curly brackets as well. So this set A is things from the universal set such that the things are even. So if we look at the universal set, by the way, A is just the name for the set. Okay? There's nothing special, it's just a name. So if we look at the universal set, which of the items in that set are even? Well, the items in that set that are even are 2, 4, 6, 8. That's it. That's our set. A is the set of things from the universal set which are even. Those things are 2, 4, 6, and 8. Okay, next let's look at a different question, or a different set. Let's look at set B. B is the things from the universal set such that the things are less than or equal to 5. If you look at the set, which things are less than or equal to 5? Well, that's just 1, 2, 3, 4, and 5. That's the set B. Okay, we could have a Venn diagram which represents this. Okay? So these hoops, okay, the hoop on the left represents the set A, the hoop on the right represents B. Now there's an overlap of things that are in both A and B, and things can be outside those loops as well. They're neither in A nor B. So that stuff is all contained within the universal set. So which numbers are in B? Well, the number 1, let's go for number 1. The number 1 is in B. Ooh, let's go back, sorry. The number 1 is in B. The number 2 is in A and B, so it goes in that thing there. The number 3 is just in B. The number 4 is in A and B. The number 5 is just in B. The number 6 is in A, but it's not in B. The number 7 is neither in A nor is it in B, so it's in the universal set, but it is not in the hoops. The number 8 is an A because it's even, and the number 9 is neither an A nor is it an B. So we can place all those numbers within a Venn diagram. Okay. We could look at some other sets now. So what is the set A and B? The set A and B is the stuff that is in both A and B. We could look at A or B. A or B is the stuff that is in A or B or both. So what is an A and B? Well, in A and B, if we look at the Venn diagram, it's just 2 and 4. The stuff that is in A or B or both is anything in hoops. So, well, sorry, let's look at a new piece of notation as well. This N is the number of items in A and B. It's the number of items, number of things in A and B. So the number of things in A and B, there are 2 things in A and B, so that's just 2. Okay, looking at this set here, A or B or both. So that was, I said, was anything in the hoops. So if you look, it's 1, 2, 3, 4, 5, 6, or 8. They're all the stuff in the hoops. The number of items in A or B, well, that's 7. There are 7 items in A or B. This thing here, this little dash, means its technical name is the complement, but really it just means not in A. Which things are not in A? Well, that's anything outside of the hoop A. So you could list those items. That's 1, 3, 5, 7, and 9. They're the things not in A. How many items are not in A? Well, that's 5 items. Things that are in, we could use this notation, not A or B. So not in A or B. Well, that's just 7 and 9. The number of items that are not in A or B, there are 2 items not in A or B. Okay, one final piece of the puzzle. Let's look at something a bit more tricky. So this means it's not in A, or it's not in B, or it's in B, sorry. So it's not in A, or it could be in B, or it could be in both B and not in A. Okay, so if I go back there, sorry. So we could shade all the items that are not in A. So that's the 3, the 1, the 5, the 7, and the 9. They're not in A. We could circle the items that are in B. The 3, the 1, the 5, the 4, and 2. So these items could be considered as not being in A, or being in B, or being in both not A or B. Quite confusing. But that's the most difficult a question can get. Okay, make sure you filled out all these notes. We'll be coming to sets in the first lesson on Monday.